Hello everyone. We will have a look at where a certain number is in pi. Since pi is infinitely long, in the decimals there will be digits which would match our number. So if we go over to the next slide, we will be using Manchin's formula, which is this, but from this great website we'll be able to put it in function, which will be called Octandenon. So if we go over a slide, the Python IDE, we will calculate this complex looking formula. So we're going to import math pi equals this, an empty string, and we'll have a look for match. Currently on the date of recording this, it's the 11th of the 10th of 2020. And then we will have pi factor b2. So now to compute this complicated calculation, we'll have a tolerance which is just a very tiny number. Remember, total equals term equals 1 divided by d, which is supplied over here. Then have n equals 0, which we'll be using, and while abs, we'll have abs because it's included in, well, it's not included in the formula, but it's to try and actually get the answer out. You'll have a tolerance, and then we'll add 1 to n, gonna divide term by itself and negative d times d. Then total will be a term, divide by 2 times n add 1. Total. So we should be it. The easy part's done. A slight flaw with my code is that it will not actually comprehend the first few digits of pi. So if you want to give yourself a coding challenge, you might want to see if you could fix my code. So now we're going to use the function. We're going to have to do 4 because in the formula it has a 4. and then we're going to use that pi factor. It must be at least 2, or else the calculations will fail and you'll just be stuck. And if a pi factor is 1,000, it'll be 0, which means the pi factor will be divisible by 1,000 without decimals. So it will execute. And now we're just going to print out the pi factor. So print out every 1,000 to just let you know that it hasn't frozen. And now we're going to use a Python function which will try and have a look for the match and in here. And then if pi.find match is not equal to -1, because the result will be an integer and we have to make sure that it has found it. We'll do print, have this ref prefix for formatting, and we'll write in found on index pi factor, add result, because that calculates where it is, which is necessary. And then we'll just break out of this loop, and then it will no longer print it. And then we'll have a pi factor add on 1. So now you can pause this video and copy that down onto the Python IDE. Okay, so now let's process it. So I'll just call this pi finder. Oh, it seems like we accidentally misspelled Octon nom with Octon Demon. So currently it's showing me an error. So and it's Octam, not then we accidentally put a bit too much C's in there, and now it will start processing, and currently it's warring, so we're just going to wait until it can process it. You might want to put your YouTube video speed to 2 times for your comfort. So you might currently be thinking, oh, this code doesn't work, it's taking forever. Well, it will eventually happen, because these length digits are usually found in the millions. Let's just keep that on. And look at that, it has found where this has appeared, in pi. 5,187,329. So you can write in whatever you want. You can do the challenge of adding the first few digits of pi. In fact, I'll have this source code in the GitHub page on GitHub, but I'll also have a GitHub file repository for the version which will have the corrected pi, so you can see if we get the same answers. So, thank you for watching, and we'll see you next time. Goodbye.